What we're going to do is we're going to use, I mean, you can see the formulas, they're lovely. We're going to use these formulas to help us make a determination of the type of symmetry, or whether there is symmetry, I should say, of a particular data set. So you have a data distribution, and aside from just eyeballing it and saying, oh, this tail looks longer than that tail, which most of the time will get you the right conclusion, how do we know the difference between like really skewed or moderately skewed or slightly skewed, other than to say, well, it's like this big as opposed to this big as opposed to that big. You know, it's like we're not really drawing any meaningful conclusions in a numeric sense. Right? It could be very meaningful in terms of just common sense, but we need the numeric sense too. Right? So we have the mu tilde sub 3. I'll explain where the 3 comes from down the line. Well, and the tilde also. But that's a different conversation for a different day. But for our purposes, it just means skewness. N is the number of individuals in the distribution. We're assuming that we're working with samples. Right? The whole first unit is pretty much related to samples. The second unit will be population information. X sub I is a specific individual in the sample. X bar, you know that, S, mean and standard deviation of the sample. All right. So conclusion, a skewness value greater than 1 or less than -1 indicates a highly skewed distribution. I mean, it's really all you need to know in terms of outcomes, because if it's between -1 and +1, there may be some skew, but it's not going to be a pronounced level of skew. All right. So, but what we will have is a comparative value, just like we do with standard deviations, where we can say this set is more skewed than that set. All right? And what does that tell us? Well, it all depends on the context. Long story short, too late, we have to get all this data in the calculator. There's 30 values. I've been emailing back and forth with the NumWorks rep, and because I asked him, I'd like to fill with a formula using a table, but I also would like to save that formula that I used for future reference. You know, because I mean, you see this. I mean, you don't even have to know what's about to go into NumWorks in order to come up with this computation to know that you want to be able to copy paste it in rather than type it every time. So it doesn't have that functionality yet, but they're hoping to have it in the next update. And they come out at like every once in a while, so every couple of months. So
where's the last one?
July, I think. Mid-July.
Could be good.
Yeah. So I'm going to type the data in. Spoiler, I already typed the data in. I did that period 4. But yeah, I mean, we're going to have to type in data repeatedly when it comes to just any kind of computation, so it is what it is. I can tell you that the first data set here corresponds to the first data set on the next page. Each set has the same sets of data. So sets within sets, subsets, as you've
This is hypothetical, but what if they made like a camera on the NumWorks where you could like take a picture of like a data set and
that
you could put it on your statistics?
that would be extraordinary. I don't think there's no like camera, but because you could do that with Excel. You know, you insert a picture and pull the data from the picture. So that would be pretty legit.
Next Shark Tank.
Yeah, exactly. So what we need to do, aside from putting this data in, because there is no pre-installed function for skewness, and I'm in the process of writing a small program, a Python program, because that's the language this one understands. So just give me a couple of days on that so I can figure it out. But hopefully we could store it as a program. You know, that'll be like the workaround. But anyway, what I want to do after I have my data in is I want to go to value v2. I want to fill with formula. And I need to get this whole thing in there. Now, order of operations is pretty important. Also having, I'll call it a rudimentary understanding of sequences and series. You don't need to, I mean, you're not doing like a limit comparison test from BC calculus or anything like that. You know, it's more like knowing what the summation is telling us to do. But one important ingredient here is, and I'll just say for example here off on the side, if I have the sum of, let's say, I going from n equals 1 to n, I'm sorry, I equals 1 to n, that would have been a disagreement. This would expand out to 1 plus 2 plus 3 plus 4, all the way to whatever the n value is. That, you should have some level of familiarity with that, but even if you don't, what this is telling us is a recipe. It's saying take this 1 and plug it in for I, bless you, give a result, and then increase by the next consecutive integer, right? So then we're going from I equals 1 to n, so the next value would be 2, then 3, then 4, assuming the step is equal to 1, all right? Now if I say that I want k times the sum of I as I goes from, or the sum goes from 1 to n, that would be k times the 1 plus the 2 plus the 3 plus the 4 all the way to the n. All right. It's like ultimate crash course on summations, which if you distribute gives you k times 1, so 1k, or just k, plus 2k, plus 3k, plus 4k, all the way to nk. Which could be shorthand written as the sum is sum from 1 to n of nk, ik, sorry. All right, because basically what I'm saying is that each component of the sum has really two ingredients. The increasing integer values from 1 to n, but each one of them has a k associated with it. All right, so that's really the longest way ever to say that you can distribute the k into the summation. All right. Last time I went over this in AP Stats, they were like, we took this class to avoid having to do stuff like this.
I didn't take calculus because of this.
But this is really nothing more than just giving you a little perspective. So what that tells us is that I can, using this big beefy expression here, I can tackle this along with the stuff inside the summation, or I could wait till after. Either way is going to give me the same answer. All right. So what we're going to do here is focus on just this part of it, and then find the sum after the fact. All right. Fortunately, one of the built-in features is summation when you're dealing with statistics. All right. So I'm going to go to my value v2. I'm going to hit fill with a formula, all right, and select empty. And now I'm going to type in x sub I minus x bar over s raised to the third power, all right, which sounds really complicated until you realize that x sub I is each of the individual values that are found in v1. The x bar we can get by finding the mean of the values in v1. And the s we can get by finding the sample standard deviation of all the values in v1, which are all built-in functions. All right, so we're making use of the functions that are already available in the calculator.
Isn't this equation similar to the sample standard deviation equation?
It has a lot of similarity to it, the x minus x bar part jumping right out. That innermost part, the base raised to the third power, that's actually the z-score formula. So we're talking about how far in terms of standard deviations a particular value is away from the mean, but then for some reason we're cubing that.
Yeah, like, could we like put it like an actual like use that sign, the what is that symbol?
The summation symbol?
Yeah, could we
the
actually
sigma
like, use
notation.
that?
You can, except for whatever reason in this area, it sort of struggles with that, because the boundaries are going to be an issue. When we say I equals 1 to n, the calculator won't know what I is and what n is referring to. So in this case, we just use the sum that's built in, but you know, it would be nice if you could actually put in the proper notation, but it doesn't always play out in numeric-based calculators. So open parentheses, I'm going to open a double because I need one set of parentheses to contain the stuff that's being raised to the third, and then one set of parentheses to contain the numerator. All right, so that's going to be V1, so shift alpha division V1 minus, now the mean and standard deviation, all that stuff comes from the toolbox. So for this stuff, we want to go toolbox, toolbox. We want to go to lists, and then we want to go to statistics. All right, so toolbox, if you come in, you know, from scratch, you'll have to go down and find lists and then go to statistics. The good news is it's going to keep that place, so the next time you go in the toolbox, it's going to bring you right there. All right, so mean. Now we're doing V1, so shift alpha V with a 1. Close it up, divide.
How'd you get that? I'm sorry, can you show me how you got that mean here?
Oh yeah, so you hit the little toolbox there next to the clear button, and then if you're scrolling down, you're looking for the one that says lists.
Okay. Yeah.
Then you'll see statistics, and then it's all there. The denominator is going to be, you got to be careful because standard deviation is an option, but we want sample standard deviation.
Wait, samples?
What's the difference?
Formula. One of them divides by n, the other divides by n minus 1. But the standard deviation formula is for a population. And since we're only working with samples, we want to stay with the sample standard deviation. All right. So shift alpha V1. Close it up and cube it. So this is what should be in your display.
Could you like restart putting it in?
Yeah, just give me a second.
Okay.
So once you do this, if you're good, you could hit OK, and it's going to populate the entire list with all the decimal values that would be computed by taking each individual x value, subtracting from it the mean, dividing by the standard deviation, and then cubing the result.
Where's like the exponent like button? On
The x to the y power. It's right below the backspace.
Oh, okay, that's really
I
weird.
did it and then I didn't have the cube. Is there a way I can just change my equation and I can re-enter the whole thing?
No, you can just go to V3 and enter a formula of V2 cubed.
Okay.
All right, so when you hit OK, it's gonna look like this. The first entry should be something like -9.37. All right, so the request was to take it from scratch, take it from the top, so I'm going to do that. So if you missed it the first time around, I'm going to clear out my table. So all we're trying to do here is get that pink expression, the one I highlighted in pink, x minus x bar over s cubed. So we go to fill with formula, empty. We need to open parentheses for the power of 3. We need to open parentheses for the numerator. So shift alpha division to bring up the V, 1, minus, we want the mean, mean's in the toolbox. So again, you go right into the toolbox, you go down to the entry that says lists, hit the right arrow or OK, go down to the one that says statistics, right arrow or OK, select mean, and then type in V1. So capital V. One of the, I would imagine, because I haven't used this calculator for too long yet, but I got to imagine one of the most popular forms of an error would be accidentally putting lowercase in as opposed to uppercase.
When did you first get these?
I first got one in May.
Oh, really?
Yeah, and then I was playing around with it on my own, and then I got some training from the company, and that kind of, like, that toolbox thing, I couldn't find it for the life of me
Yeah,
early on.
Those symbols are weird.
Yeah. It takes getting used to, but once you do, it's pretty powerful. All right, so I'm going to close up parentheses for the mean. I'm going to close up parentheses for the numerator. I'm going to divide, and that's going to take my entire numerator, put it in the numerator. All right. Otherwise, if you didn't do that extra set of parentheses, it would just take the mean and make a fraction out of that. So we want to have that extra set of parentheses. All right, so then back into the toolbox, sample standard deviation, popping in a V1, shift alpha division with a 1. That we don't have to worry about extra parentheses, just close the one that came built in to the sample standard deviation method. All right, so close it up, raise it to the power of 3. So that's that x to the y power key right below the backspace. So select that, and you'll see a nice power of 3 emerge in beautiful math print form once you type the 3 in. So then hit enter, or okay, well, execute. Yeah, the x to the y button for the power, for the any power.
Oh, I can do that all over again.
All right. Now I want to take the sum of everything that comes up in this list. Actually, do that. I'll put it in the notes later. I want to take everything that comes up in this populated list, add it together, and then multiply by the n over n minus 1, n minus 2. All right, so I'm going to hit OK. We have all these values here. Now, I want to go into stats because I don't want to have to type that out and add it all up separately. So I go right up into stats. And if you go into the V1N1 list and scroll down, you'll see the option, it is a sigma x, the sum of the x values, all right? Specifically in V2, all right? So I have 2.56, whatever. I don't want to have to write that down and type it out again. So I'm going to just do a quick copy. So copy is the var key right next to the toolbox. So shift var, and I'll have a copied value. All right, so when I go into my home screen, my calculation screen, and paste it, that number comes out. So you go right onto the number, shift var for copy, go into the calculation screen, shift toolbox, and that'll paste it. All right. So then I'm going to take that and multiply it by n over n minus 1 and n minus 2. The n is the number of values in the set. We don't have to do anything fancy there. The number of values in the set is 30. So 30 divided by 29 times 28. All right, when you hit enter on that, or OK, or execute, it gives you your skewness value.
I got negative 3.78 by sigma. I don't know why.
I actually got the same thing.
Negative 3.78.
Yeah.
Oh. All right. Well, let me actually stop the recording here.